Okay, welcome to our 1.6 concept video. In our previous section, we just finished talking about various rules for derivatives, which really translates to shortcuts. Various ways that we can make derivatives much simpler. So we talked about the sum and difference rule, the constant multiple rule, and the power rule. And so at this point, we can now take derivatives of, say, polynomials really easily instead of having to use the limit definition or the difference quotient. But today we're going to look at, okay, so what if we have a product of two functions? Or what if we have the quotient of two functions? So let's start with that first question. What happens if I want to take the derivative of two functions that are being multiplied together? Remember, this d over dx notation just means I'm taking the derivative. Remember, we've already looked at the case if it's addition or subtraction. That was my sum and difference rule. And if we remember, if I have two functions that are being added or subtracted, you can just take the derivative of each of those separately and then add or subtract them, right? You can just focus on the two functions individually in order to get your derivative. So does the same rule apply? Can I just take the derivative of each function individually and then multiply them? That sure would be nice, right? That would be a really easy way to take these derivatives of two products. Well, there's an easy way to check this. Consider this function, my x squared function. Well, we already know the derivative of this function because this is a simple power function, right? I know my derivative is 2x. But I can also write this as a product of two different functions. X times x is just x squared. And if I write it like that, then I can think of that as two different functions. One function is x, and the other function is x. So try using this rule up here. If we try using this rule, then according to this rule, what would my derivative be? My derivative would be the derivative of x times the derivative of x. Well, what's the derivative of x? The derivative of x is 1 times the derivative of x is 1. And of course, that doesn't match. Those two things are not equal. So therefore, multiplication is going to work much differently than addition and subtraction did. This rule that we just tried does not work. I can't just take the derivative of each of them separately and then multiply. Instead, I have to use what's called the product rule. So the product rule tells me that if I want to take the derivative of two functions being multiplied together, we're using g and h as my example functions, then what you actually end up getting is the derivative of your first function, g, multiplied by the original function, h, plus the derivative of your second function, so h prime of x, times your original first function, times g of x. And that's what's called the product rule. That's how you take the derivative of two functions that are being multiplied together. Interesting, huh? Well, let's put this to practice and see if it actually works. Let's go back to this example over here of x times x. Well, according to my product rule, if I want to use my product rule on this function, what would I get? I would get the derivative of my first function, which is 1, times my second function, which is just x, plus the derivative of my second function, which was 1, times my first function, which is x. So I get 1 times x plus 1 times x, which is x plus x, which is equal to 2x. And sure enough, I get the same thing that I got when I used the power rule. And so we can see that this rule actually works if you have two functions that are multiplied together. So this is how you'll see it on your formula sheet. But I do want to emphasize the fact that because this is addition, if you mix up the order, that's okay. The order doesn't matter. You could do h prime times g first plus g prime times h, and it's still going to work just fine. It'll still give you the same answer. So that's the product rule. But something to keep in mind so far with what we've learned, right now we only have the derivative rules or derivative tools to really tackle polynomials, right? So consider this example. Let's consider this function f of x is equal to 2x squared plus 5x minus 3 times 3x cubed plus 1. So here I have a function of two polynomials, and let's say I wanted to find the derivative. Well, we now have a derivative rule when I have a product of two functions, right? I consider this my g function and this my h function, and then I can use the product rule. But because I'm working with two polynomials, I actually have another option. I could also just multiply these two functions together using my foiling method, right? Where I just multiply every single term together. And if I do that, I'm going to get 6x to the 5th plus 15x to the 4th minus 9x cubed plus 2x squared plus 5x minus 3. And now I have this big, long, fifth order polynomial. And with this, I don't need the product rule. I can take the derivative of this just using my sum and difference rule, my constant multiple rule, and my power rule. And I would get 30x to the 4th plus 60x cubed minus 27x squared plus 4x plus 5. So if I'm working with a product of polynomials, I don't have to use the product rule. If you're more comfortable foiling, then that's another option you can use. And in fact, I think there's some homework problems where it asks you to do both. And we'll probably go over one of those in our examples video. But regardless of which way you do it, you should end up with the same answer. So let's try it using the product rule and make sure that we get the same thing. So when I use the product rule, I'm going to do, we've got it right above us right here. So I'm going to do g prime, which is 4x plus 5 times h, which is my second function, 3x cubed plus 1, plus, and now I'm going to switch that. I'm going to take the derivative of my second function, which is 9x squared, and multiply by my first function, 2x squared plus 5x minus 3. And now, of course, right now, these two results don't look the same, but that's because one of them still has a bunch of multiplication happening in it, and the other one is fully simplified as a fourth order polynomial. So let's simplify this to make sure we get the same thing. When I simplify this, I get 12x to the 4th plus 15x cubed plus 4x plus 5 plus 18x to the 4th plus 45x cubed minus 27x squared. I have some like terms here, right? I've got x fourth terms. I've got x cubed terms. I can combine those terms together to get me 30x to the 4th plus 60x cubed minus 27x squared plus 4x plus 5. And sure enough, we get the same answers. So either way works. If you have a product of polynomials, you can choose to either use the product rule, or you can just multiply your polynomials first and then take the derivative. Well, that takes care of the product rule. Now, what do we do if we have the quotient of two functions? So, what do we do if we have two functions that are being divided by each other? Now, this circumstance is actually going to be way more common than having the product of two polynomials. Like we said, you don't really ever have to have a product of two polynomials because you can always just multiply them through. But if you have a quotient of two polynomials, if you have a polynomial over another one, there's nothing you can do to simplify that. Or at least, there's most cases, there's nothing you can do to simplify that. And so you're stuck with a function over a function. So we need a good derivative rule for how to deal with these fractions of functions like this. So you'll notice I changed the notation a little bit to n of x in the numerator, n for numerator, and d of x in the denominator. So, and you can probably guess that it's not as simple as just taking the derivative of the numerator and taking the derivative of the denominator and calling it good. Right? It's not that simple. Instead, the quotient rule is going to look kind of similar to the product rule. You're going to take the derivative of your bottom function and multiply it by your top function, not taking the derivative. And then you'll subtract the other way around. So the derivative of your numerator function multiplied by your denominator function. And this will all be divided by the denominator function squared. Now, if you're curious about where this rule comes from, I'd encourage you to look up a proof of the quotient rule. Same thing's true for the product rule. If you're curious about where this product rule comes from, I'd encourage you to look up a proof for it, to kind of look at where it comes from. Why do we have this rule? But this is the quotient rule. And I want to point out something that now it's subtraction. That's one of the differences. So, with the quotient rule, the order does matter. We always start with the derivative of the bottom times the top function. And that's where it'll be nice. You'll have this on your formula sheet to always reference when you're going through this on the exams. So that's the quotient rule. That's how it works. So if I were to take those same two functions that we were working with earlier and use the quotient rule on them, let's see. Let's do 2x squared plus 5x minus 3 in the numerator and 3x cubed plus 1 in the denominator. And if I wanted to take the derivative of that quotient of functions, then I could use this rule right here. I would take the derivative of the bottom function, so 9x squared, and multiply it by the top function, minus the derivative of the top function, which is 4x plus 5, multiplied by the denominator function. And then all of that would be over the denominator function squared. And that would be my derivative. Now, there's a lot of simplifying that I could still do, right? There's a lot of multiplication that I can do in the numerator, but for the sake of this video, I'm going to go ahead and stop it there. But you'll notice how quotient rule and product rule are kind of similar, and that makes sense because multiplication and division are related operations. But just to kind of show you what we did here, right? This represents the derivative of my denominator function. This is my original numerator function minus the derivative of my numerator function multiplied by the denominator function. And then this is my denominator function squared. Okay, go ahead and try out the homework. Go ahead and get started on it. And then if you have questions or if you get stuck, you can come watch my examples video where I'll go over a couple of the problems from the homework. Thanks, guys.